The set that we have in section 2.6, okay, we're looking at polynomial and rational inequalities. And we have for number 1, okay, we're looking at solving for x, whereupon we have x squared minus 10x is greater than or equal to negative 24. And if I rewrite what I have here as a comparison to 0 inequality, all right, so we have upon adding 24 to both sides, so we have that x squared minus 10x plus 24 is greater than or equal to 0. And looking at what we have and just expanding what we have here, okay, so we have upon factoring, okay, we have the quantity of x minus 6 times that of x minus 4 is greater than or equal to 0. All right, so if you were to determine the zeros from this, where we have the expression equal to 0, so we have from x minus 6, so we have that x is equal to 6, and from x minus 4, we have that x is equal to 4. So we have, in the case of our zeros, and I'm just going to rank order the variables in increasing order. So we had the zeros again at 4 and 6. Now, in terms of setting up what we have here, and we have establishing a table. And taking what we have, so just have some headings here. So you have an interval, and starting from negative infinity, approaching 4, but not including 4. And then we have going past 4, approaching 6, but not including 6. And we have for the remainder, since no other 0 exists, so going past 6 and heading on out to infinity. All right, and so we have, first of all, okay, we can ascribe, or in this case, insert test values. And we can choose a value at random that is less than 4. We can go with any number, could be 3, 2, 1, 0, anything that is negative. We'll just go with the number 0. Now between 4 and 6, we have only the value 5. And we can select any value greater than 6 to test out, okay, the last of the intervals. So we'll just go with the number 7. Okay, and now, and just for what we have in separating, since we draw these vertical boundaries, and again we have testing out. So again we have, when we rewrote the inequality in terms of comparison to 0, okay, we had the trinomial x squared minus 10x plus 24 . All right, so testing out the first of the subintervals. Okay, so we have f of 0. So if x is 0, so you have 0 minus 0 plus 24. So you have f of 0 is equal to 24. And in the case of what we have for f of 5, okay, so you have f of 5. Okay, we have, in this case, you have 5 squared is 25, minus 10 times 5, we have negative 50. And 25 minus 50 is negative 25 plus 24, so this will come out to negative 1. And in the case of what we have with f of 7, okay, 7 squared is 49, negative 10 times 7 is negative 70, and got 49 minus 70 is negative 21 plus 24, so this will come out to 3. And I'm going to stress the sign values. Now, looking at what we have at this stage. And we have, for the determination of what we have for the sign values. Okay, so I have for the sign of f of x. Okay, so anything we plug in for x that is less than 4, okay, now the result is going to be a positive value. Anything we plug in greater than 4 and less than 6, okay, in this case 5 is a test value, the result is going to be negative. Anything we plug in greater than 6 is going to result as a positive output. So in the case of what we have here, if you had the output to be positive, then you have f of x is greater than 0. And if the output is negative, we have the f of x is less than 0. All right, so for what we have in the case of the comparison to 0 inequality, again, this had condensed to x squared minus 10x plus 24 is greater than or equal to 0. And in this particular case now, we'll be looking at the limits for what we have in the case of starting out where we have the function to be positive. So we have with the limits. Okay, so you have between negative infinity and 4. And since the inequality includes the 0, now again, infinities are balanced, so they will stay in parentheses. Now we have with 4, since 4 is a 0, and since the inequality is inclusive of the equal to 0 notation, okay, so 4 is going to be enclosed. And then we have for the other subinterval, okay, so you have starting from 6, and since you have equal to 0 in the inequality, okay, 6 is going to be in the bracket, and we have on out to infinity. All right. So in terms of what we're going to have from a graphing standpoint, okay, so you have going from negative infinity approaching and including 4. So if we take what we have here, so we have 4 is included, and then we're going to have going continuously out to the left. Notice you have a value at 6, and then you're going to have an array that will go continuously out to the right, and then checking. Okay, for what we have in the case in number 2, we're looking at the product of 3 binomial expressions to be less than 0. And if we go ahead and identify the zeros of each factor, so you have x at negative 2, x at 4, and x at negative 6. So we have, upon identifying the zeros, and just to rank order from smallest to largest, so we have negative 6, negative 2, and positive 4. Now, and just setting up a table. And again, we have among our intervals, so we have starting from negative infinity, approaching but not including negative 6. And then we have going past negative 6, approaching but not including negative 2. We have going past negative 6 to negative 2, and then we have going past negative 2, approaching but not including 4, and with 4 as the highest 0. So you have going past that and heading on out to infinity. Okay, and again, we're going to insert tested values. Okay. Also, we'll have just for the function values to have f of x. So again, we have the quantity of x plus 2 times that of x minus 4 times that of x plus 6 Again, we're looking at the sign of f of x. All right, so we have in forming the table and separating what we have in the case of the rows and the columns. Okay, now for the tested values, we can plug in anything for x that is less than -6, so we can go with -7. Anything between -6 and -2, you might go with -5, -4, or -3. Anything between -2 and 4, you can just go with 0. And anything greater than 4, we can just go with the number 5. Okay, and now, so we have looking at what we have for each of the outputs. Okay, so again, we're not stressing the exact value so much, but in the case of the inputs, they have f of -7. So -7 plus 2 is -5. -7 minus 4 is going to be -11. So you got -5 times -11 is going to be, in this case, positive 55. And then we have times, okay, -1. So f of -7, this will become -55. In the case of -3, -3 plus 2 is -1. -3 minus 4 is -7. -1 times -7 is going to be a positive 7. And then we have times 3. Okay, so we have for f of -3, this will be a positive 21. In the case of what we have with f of 0, okay, so we have 2 times -4 is -8 times 6 is going to be -48. And we have in the case of 5, okay, so we have 5 plus 2 is 7. 7 times 5 minus 4 will be 7 times 1 is 7. And we have 7 times 11, so we have f of 5. It's going to be a positive 77. And okay, so taking what we have now, okay, so we have in the first setting, okay, so we have so having this one, okay, so we have for f of -7 equal to -55. Okay, anything you plug in less than -6, the output is going to be negative. So we have that f of x is going to be less than 0. And then we have for next item, okay, so you have a positive. So we're going to have the f of x is greater than 0. Then we have next, okay, we have negative sign. So we have the f of x is less than 0. And for what we have in the case of the last interval section, so again, we have anything that we plug in greater than 4, the output is going to be positive. Okay, so we have that f of x is greater than 0. Okay, we have in the solution, okay, where we had to be less than 0. So we have values of x that will be less than -6. And also we have values of x between, but not including, -2 and 4. So in transferring this bit of information over to what we have in Aleks, checking, and the result is correct.